try to solve Leetcode problem still game 4, and this game will be a little bit different from the previous 3 still games, and the value of n gonna be just a number, and this gonna be from 1 to 10 to the power of 5. So Alice will also start first, but for each of the turn, the player can make a move consist of removing any non-zero square number of stills in the pile. So let me just give you an example. So if my piles is 1, so I can remove any squares. So 1 square, it is 1. So for Alice, I can remove 1. But for Bob, it is 0. And while it equal to 0 for Bob, this means Bob loses. So Alice gonna win. So we're gonna return true. And if equal to 2, definitely it's gonna be a false. What about 4? So for number 4, so for Alice can take 2 square, and 0 gonna be for Bob. So Bob loses, Alice and wins. Yeah, because Alice will always choose optimally, and also for the Bob. The idea for solving this problem is that there may be a lot of different combinations for the Bob. Yeah, so maybe a true or false, false or true. Yeah, but for all the combinations for the Bob, if one of them is false, so definitely Alice will win the game. Yeah, because if there is a possible, if there is opportunity, because for Alice, I'm gonna define the function for the DFS. It's gonna be if Alice plays optimally, and this DFS gonna decide whether Alice win the game or not. So it's gonna be a Boolean value for the Alice. But instead of attacking Alice directly, I'm gonna attack for the Bob, because for the DFS function, I'm gonna use the DFS for the Bob. So if this DFS for the Bob definitely is a false, if it's gonna return a false for the Bob, definitely Alice will win the game. Yeah. So let's try to get started. So we're gonna define a class, and for the DFS gonna prepare I, and this I gonna be 0. So I'm gonna call the function and gonna start from this I is equal to n, not 0. So I will start from this number n, and I'm gonna check if this I equal to 0. So this means whether it is Alice or Bob, definitely loses the game. So for the DFS, I'm gonna return a false. Now I'm gonna check all different combinations. So I'm gonna check the int of a square root value of this I to 0 to -1. Because definitely I don't need to have a value of 0, so I'm gonna have the minimum value to be 1, because it means 1 square to this number's square. Basically it is less than or equal to n. Yeah, I need to control that all the values, square values, should be less than or equal to n. Now I'm gonna check the conditions if Bob loses. So it's gonna be the DFS I minus z square, z times z. So this means Bob loses a game. So for all the combinations, yeah, so this is a for loop for all the combinations. If there is one opportunity, Bob loses the game. So definitely Alice will win. If Bob never loses the game, yeah, there are so many combinations as I explained, and Bob never loses the game. It's gonna always be true. Bob never loses, so definitely Alice will lose. But if one of the opportunity Bob loses the game, so Alice wins, because Alice just needed to have one time to win the game, and then we're gonna return true. So this is the idea of the question. Yeah. So Bob, in order to win the game, so for each of the combinations, Bob should always win. If one of the combinations is a lose, definitely Alice will win the game. So finally, we're gonna return a false. So this means Bob will always win the game. So I'm going to return false for the Alice. Otherwise, I'm going to return true for the Alice. So this is going to be the entire code. As you can see, it is not so long. But the idea is important for us to analyze the game theory problem. Yeah. We just need to understand the question and try to use the game theory. Basically, it is a dynamic programming. As you can see, it is pretty fast, and the time complexity is O(n). And for this value, and we have a DFS with I, and this value of I may have 10 to the power of 5 different cases. So we're going to use that. But actually, while for the calculation for different testing cases, normally this I going to be smaller than that, but that is okay. Thank you for watching. See you next time.